Let us discuss one more important operations on Q is called DQ. So now we have understood how NQ operation is performed with the Q. So now let us learn about how DQ operation could also be performed with the Q. So that's deleting an element from the Q. So how you delete an element from the Q, that's we are going to write now. So before that, let me rub this. So let us look at the as usual. So whenever we try to delete an element means so we try to delete the elements. So we perform the deletion operation only when there exist elements. So when you have a queue that consisting of some elements, then only think of removing that element from the queue. If it's an empty means I cannot perform the operation of deletion. So therefore DQ algorithm does not work. So therefore first what is the condition is we have to check the queue is empty or not. So already we have known how do you check the queue is empty or not? So that is very simple, as you know, that is using front equals null. So if front is null means it indicates the queue contains nothing. So it's an empty queue, hence this DQ operation cannot be performed. So you can display the message saying that so the queue is empty. So otherwise what you can do means so there exists some element, one element or more element, we don't know, just delete it. So after deleting this, what we have to do means then you have to worry. So we have to think which is the next element to be deleted. Therefore, the front pointer has to be adjusted. It has to move to the next position where the next element to be deleted is present. So therefore, so if you delete an element, imagine this is the only one element is there and you remove, then what you have to do so we have to make front is 0 and null is also 0. So otherwise what happens, there already exists like this some element, you deleted this, front equals front plus 1. So simple. This is how we perform the DQ operation. So how this pointer, when do you say there was only one element? How do you decide that the queue contains only one element means after deletion? So we perform the operation is equal to front equals rear. If front equals rear means that that condition will give you that queue is has only one element. So therefore after deleted that element the queue becomes empty. So therefore set the pointer front equals null and rear equals null. That is they have no relation with the arrays. That's how indirectly there is no queue, that becomes empty queue. So that's what we are trying to do, this one algorithm. And if you understand this concept simple, so then the writing queue becomes a very easier. So what is actually I said means, so first you have to whenever you are trying to perform the deletion operation, if it is like this means I cannot perform deletion, that is queue is empty. So first condition, first what you have to do is check the queue is empty. So if it is empty, give the message we cannot perform, that is we can say it's overflow. If it is a queue is overflow whenever inserting, this is you can write the message it's underflow, or you can write it's queue is empty, stop with the message, any message you can give. So more means overflow, so it is less mean there is nothing means it's underflow. They may sometimes they use the word overflow for full, or the underflow for empty. So you can use it, that doesn't make difference what you use, that depends according to your normally it's queue is empty, queue is full, I consider is better than overflow, underflow. That's also correct, this is also convenient, which is we are familiar with. So therefore that is what we have to do first. If it is empty, the queue is, that's where decide front equals null, the queue is empty, quit, that is go to the end of the algorithm. Otherwise just remove. So when it is not empty means there exist elements, just delete it. So after deleting, check what is the next element to be deleted. Their front has to be shifted, that has to be moved. How do you make this one means you check. So if you have deleted the element and there is possibility that is the only one element which is present in the queue, that is options, otherwise it may be some element. So if it is only one element, the concern is very important, because after deleting that element, so next time you try to delete means it has to give the message that said front point should be null. So therefore we have to reset. So f should be becomes null and rear also becomes null. So that is what we are going to do whenever there is a front equals rear. That condition will decide there was only one element, so therefore make front equals 0, rear equals 0. Else, otherwise there exists f equals f plus 1 and stop the algorithm. This is how we are going to do this deletion operation. Let us write an algorithm. Step 1 same as usual, let A be an array, that Q be an array with n elements. This algorithm deletes an element from the queue and it is copied to the item, and front is pointing to the front end, first element to be deleted, and rear contains the point last inserted element. So this is some description. As usual we know that's we have to write down, then we have to write this algorithm. So what this algorithm says now? So what you have to do whenever we perform first step in deletion operation is to check is it empty or not. How do you check? So front. So if front is null, if front pointer is null means so q is empty, there is not to do much. So therefore output can write q is empty. Go to stop, write step number if n, this is over. The next step number 3, yes, it's not empty, there exists some element, just you delete it. How do you delete? From where we are deleting? So item will be, it's a variable name, it is from q, that is array q. If you take, I took, can you use the capital letter? No problem. No, whatever the name of an array, let it be q. So q of, don't use rare because I am trying to delete through the front end, deletion always from the front. So therefore we make front. So this is how we get confused. Sometimes we write rare here also in the exams. So then your whole algorithm goes wrong. So be careful with the pointers. That's how it's very difficult. No, that gives something else. You deleted the wrong things. So that's because machines will do like this only. Then it may cause trouble when you write software. So therefore we have to be careful. These are the basics operations we must remember, otherwise it changes. So indirectly which end? Front end. Whenever deletion, front. Insertion, rare. In top, in the stack it is not like that. So both through the one and only, top only, that doesn't make difference. But here it is, you have to be careful. So after deleted, next step is check. How is this the only element did I delete it or exist more element? So if after deletion, if front equals rare, that indicates we had only one element. So therefore you make front null so that q is empty. Rare is also null. So this makes the condition of q is empty. So else means it is not the only element. I have deleted something like 4. Next element to be deleted is front equals front equals front plus 1. Increase the pointer to the next. Next is step number 5. I'll write stop. The algorithm stops. So go to step number 5. So this is the algorithm that is going to delete an element from the queue. What it is trying to do here is means, look at this, it's empty, I cannot perform the operation, we quit. The second option is, you can see here, there was only one, I deleted this. So after deleted like this, item copies 4, front is equal to rare, yes, both are same. It may not be any number. So if it is first element, imagine this one. So you deleted this and you deleted, and what is front and rare are same. So like this, you can imagine now front is also 2, rare is also 2. So that's where we have reached. Then what happens? The stop. So that's what we are trying to do. Front is equal to rare means delete the element. Well, there was only one element because this is how it looks, because I want this example for the next one, no problem. Look at this now. You deleted 5 and front is also 2, rare is also 2. We reset to null. So deleted this, there is no more element. Example. Otherwise what happens? You deleted this 2, then make front equals front plus 1. So this is how the deletion operation DQ algorithm is performed with the queue. I think it's very simple. So we have practical program also. So we'll do it in the practical. I'll do this programs next class. When I get programming concept, I'll start. So then I'll write programs for all this, stack programs, queue programs. I'll do it. So all these programs I'm going to do which is in the lab manual, and we are going to do these things. Okay, no problem. So this is algorithms are important. Sometimes they ask for 3 marks, 5 marks. Both algorithms they may ask 2 marks. Sometimes they'll ask. So what is the NQ function? They may ask what is the DQ? Define NQ, DQ, and write algorithm for NQ or write algorithm for NQ, DQ. All are very simple and very interesting, and also define different types of queues that maybe they ask in the exams. So all theory critical, so it's very simple, there is not much complicated, very simple basics mathematics, simple comparison, just addition, subtraction, moving the pointers here and there. Very simple. Computer science is definitely going to be easy comparatively other subjects. I don't, not like other subject. Generally, it is if you have a just common sense, it's computer science is much easier. I think we have a short notation. What is do you study means CS? CS means we say computer science. Synonymously you can call, not technically you can also think like this. This is a computer science. That is a common sense. So computer science and common sense is the most closer. So we should have that common sense, simple things. Then only computer science becomes much easier. So let us we learn the application of this Q. So when you have like this organization, what are the uses? So one is called simulation. So simulation, there is a one topic in computers you might have seen. Simulation means a method of modeling the system. So there are many places we come across. When you see the cricket you might have seen. He is out or not, LBW, leg before wicket, yes or no, something they ask for third umpires. That's a simulation. So what is there on the field is happening. The same thing we do it in the system and we watch closely how it is. Where the ball is hit the ground and it is in the is going to miss the wicket, or it is going to hit the wickets, or it goes above the wicket, or something like this. All this calculation you might have seen, and it shows the image, and it ball sometimes goes hit the bills of the wickets, or sometimes it is missing the wickets. There are so many possibilities. So how this we have seen on the computer means that is called simulation. That's a simple example where you can understand. But you go for IR studies, most of the things you can do simulation. Whatever you're interested, that simulation is method of modeling the system. There is some system working, and you have to bring that concept into your system. Means there, that you have to do it on the machines. Maybe sometimes many dangerous experiment. There is a big topic. You will be simulation is a one big unit you can study in computers when you go for IS studies, and that there in that places we use, because you see there that application. It's like this application software programs you are writing. So there you have to use this Q. Even stacks also used in simulation, not only particularly, but in simulation, certain simulations we use the Q. The second one, what we are talking about is the various features of operating system. So operating system, there are multi-programming, multitasking, round-robin technique, and time scheduling algorithms, and all these things. So in system software, in computers, normally printer server routine works. Normally what happens when computers are connected to the network, or maybe you have a printer, what happens when you give commands, so you try to print 10 pages, different pages, you again print. So how it prints, all the print has to be done one by one. So then before it start printing, so there is a number of jobs formed. So this has to form a queue, and one by one it has to be done. So operating system tracks this one execution one by one correctly, means this is how it is going to do. That is because of the queue data structure. So whatever your jobs or tasks, whatever it is inside the digital system or computers I am talking about. So there we use this type of queue. That's most of the operating system software it works, and various system application software when we write, there also we use. So the most important is generally you technically want to write it in the exams, means one is simulation and various features of operating system, and multi-programming system platform, and multitask system environments, and also you can use many scheduling algorithm. Time scheduling algorithm is there also we use. Time scheduling means CPU, different types of operating, that is we have studied about last year operating systems. So there we have studied CPUs, time scheduling. So how this CPU is allotted for different process, the forming a queue one by one, and also like round robin technique, that's also associated with operating system features. So this where the job has to be organized, because CPU is much faster to work with the speed of the CPU. So therefore we use the resource allocation. So it is a rotation. CPU will be rotating. So the rotation is in such a way that so every iota of time, small amount of time is spent with each job, and it rotates. So then what happens? So you can execute much faster, and there is necessity of forming a queue. So then how do you form the queue? Means we use this data structure, linear data structure queue. So that's also we use, and printer server routine. Sometimes there also we use this one, and also they are used in one more is application based system application software based on this what we have queues data structures. So these are some any 5 they may be asking in the exams. I mentioned the 5 application of queues. So you learn these 5 applications. There will be, and sometimes 5 marks. sometimes 2 marks, 3 marks, and also 1 mark they may ask expansion of P4. That is first in, first out. Which data structure follows the principle of FIFO? That is Q. Which data structure follows the principle of LIFO? Last in, first out. That is a Q. That is a stack. Sorry. So this is something about data structures. What we have studied so far. And next class we'll start a different topic. I think this because I have next is a linked list. Let me come across with after we have a memory allocation, dynamic, static, and dynamic memory allocation. There we have a chapter called pointers. I want to explain pointers. So therefore, after explanation of pointers chapters, I'll come back to this linked list, and also I'll continue with the remaining rest of the data structures. So this is like almost we have a trees, nonlinear data structures, and this linked list. So that will continue the next class. That is after completion of pointers, we'll come back to this topic and we'll continue. This is something about data structures, what we have studied so far, and we'll start in the next class. Okay. So write the assignments, notes, and then whatever the problems, that's algorithms, some problems is there, and also if you look at the exercise, all 1 marks question, all 2 marks question, all 3 marks question, all 5 marks questions, you're going to write, and all, as I told, in the papers, and keep them, so during exams it becomes easier. So maybe when college starts, we don't know, but whenever college starts means, so it becomes very important to learn all those things. Don't waste your time. I don't know how you're doing, whether you're reading. Whenever I try to see means you are spending 2-3 minutes. I do not know whether you are able to complete everything, or you skip and just you finished or something. Anyhow, but it's important. So try to understand, learn everything, and do it. That's more important. That's what we have to focus, because if you don't do it means problem for you only. Exams will definitely come, and then don't think I will going to do all those things. There is all like physics, chemistry, maths, computer science, Kannada, English, all are important. So therefore, just do that day work that day itself, so that it becomes easier. Okay.